Hello students, I am Dr. Navjot Kamal. Welcome you all to our next module on development and physical construction of hard disk and CHS and LBA addressing. Dear students, in our last module we learned about many types of primary, secondary storage devices like RAM, ROM, flash drives, optical disks, magnetic tapes. But one of the most important device from the forensic point of view is hard drive. Mind it, the most important device. It is also referred as the black box for retrieving the information. Why? Because it is one of the computer's non-volatile and persistent storage media. So there is always a good chance to extract some information regarding web history, information regarding deleted files, information regarding obscene images or MMS. All it is stored in the secondary storage device. So it is almost mandatory for all of you to know about the construction, working, data storage and addressing system inside this hard drive. That is all we are going to cover in our today's module. First of all, do you know who invented the hard disk? The hard disk was invented in 1956 by IBM team led by Ray Johnson, who is considered as the father of disk drive. And do you imagine the size of this first commercial hard drive, that is RAMEC 305? It was about the size of 2 refrigerators and weighed about a ton. Each RAMEC record file contained 5 million characters and in a stock of 50 disks. From that 1 ton, we have almost reached to few grams and transformation of storage capacity from few megabytes to gigabytes to terabyte and so on. The modern hard drives have come a long way to acquire the present specification. So let us know a bit about the history of hard drive. With the invention of RAMEC 305, the IBM ruled the market of hard drives for many years, almost 6 decades. Few of the important versions of hard drives which are introduced by IBM are IBM 1301 disk storage unit in 1961. IBM 1311, the first removable hard drive with a memory of 2.6 megabyte and was having just 6 disks. It came around in 1963. Next was the IBM 2311, which was first standardized disk drive. The quality of this drive was that it could be used across multiple versions of systems. And in 1970, the Western Digital Company, which was earlier known as General Digital Corporation, was established. In 1973, the IBM introduced Winchester Drive with 3 removable sealed data modules. And it is very interesting to know about the origin of this name. Since it has a storage capacity of 30 megabytes, and a 30 millisecond access time. So the inventors name it Winchester in honor of the 30 caliber rifle of the same name. Tell me why I am telling you about this story. Because this name is still relevant in the modern fixed hard drive system. Because they follow the same model as that of earlier Winchester model, where disks are completely enclosed in an airtight sealed unit and cannot be removed from the disk drive. Moving further, IBM introduced its Piccolo drive having the storage capacity of 64 megabytes over 8 disks in 1979. By this time, there came the Seagate company, which is still ruling the market, but IBM continued with its products with introduction of 3370 model, which was the first to use the thin film heads in 1979. And then with the revolution of personal computing in 1980s, IBM introduced the first gigabyte capacity disk drive in 1980, the 3380. In 1983, the first 3.5 inches drive was produced by Scottish company Rodyne. The drive had 2 platters and could store 10 megabytes of data, where in 1986, it witnessed the introduction of SCSI interface, a standard used by the Apple's Mac Plus. But Prairie Tech released the first 2.5 inches hard drive in 1988, designed for use in notebook computers and laptops. Now, with the demand of more compact disks, IBM released its 0663 Corsair drive in 1991. The first drive to use the magnetic resistive heads with 1 gigabyte storage capacity and with 8 disks. Hard drive continued to become smaller with the launch of 1.8-inch disks in 1991 and 1.3 inches HP Kitty Hawk hard drive in 1992. In 1997, IBM introduced first hard drive to use giant magnetoresistive heads, the 3.5-inch Titan, with the capacity of 16.8 GB, and in 1998, its first micro drive, which stored 340 megabyte of data. And then there was major change in the market when IBM made an agreement to combine its hard disk drive operation with Japanese company Hitachi Limited, forming a new company called Hitachi Global Storage Technologies in 2002. In 2003, the first SATA drive was produced by Seagate. Hitachi developed the first 500 gigabyte drive in 2005, followed by the first terabyte capacity drive in 2007, where the first 3 terabyte hard drive by Seagate and Western Digital was released in 2010. From there, the gambit of hard drive disk manufacturing is with 3 dominating companies: the Seagate, Western Digital, which acquired Hitachi, and Toshiba. So after knowing about the history of the development of the hard disk, let us now talk about the modern day fixed hard drive, that is called HDD. A hard disk is a sealed unit containing a number of hard, rigid platters in a stack, therefore named the hard disk. A typical hard disk can have anywhere from 1 to 5 platters. The number of platters can affect the weight and cost of the hard drive. So the new type of the drives with 1 terabyte capacity or lower than that are using single platters to reduce the price. Today's hard drive are actually fixed hard drives. Fixed because they don't have any removable platters in comparison to earlier hard drives that had removable platters. Such fixed hard disks reside in a drive bay inside the computer case and are connected to motherboard using an ATA, SCSI or SATA cable, thus named accordingly as IDE, SCSI and SATA type of the hard drives. The platters used in such type of the hard disks are usually made with aluminum alloy or a mixture of glass and ceramics. The later one, that is mixture of glass and ceramics, has been in trend because of the better heat resistance and smoothness properties. These platters vary in size depending upon the make and model by the manufacturers, called as the form factors, where the conventional hard drives come in 2 standard form factors, that is 5.25 inches and 3.5 inches, where the laptop drives are usually smaller and have 2.5 inches as the standard form factor. Such platters are mounted in a horizontal position on a common spindle, and to move this stock of platters to its axis, there is a spindle motor which runs at a speed of 3600 revolution per minute to even 10,000 revolution per minute, and even more than that, that is 15,000 revolution per minute. And do you know the word drive in the hard disk drive was added in reference to this heavy motor that is used to spin these disks or platters. To allow the data storage, both sides of each platter, that is top and bottom, are coated with a magnetic medium. Formerly it was magnetic oxides were used, but now almost exclusively a layer of metal alloy, usually a cobalt based alloy, is used. So data is recorded by magnetizing this ferromagnetic material. Dear student, as we repeatedly say that information is digitally stored as 0 and 1s, so the magnetized spot on the platter is used as 1 and a non-magnetized spot is considered as 0. Now, to read and write information on the platter, a set of special electromagnetic read-write devices called as heads are mounted on the sliders. These sliders are further mounted on the arms, all of which are mechanically connected to a single unit called as actuator. These heads are not actually touching the platters. Rather, the rotation of platter keep the heads away from the surface of the disk. On early hard disk drive, this distance was around 0.2 millimeter, but in modern drive, this has been reduced to 0.07 millimeter or lesser than that. Due to such a subtle and susceptible construction, where a small particle of dirt could cause the head to crash and abrasion of the magnetic coating, the inside of the hard disk drive must be kept dust-free to eliminate the chances of internal contamination. Air pressure is equalized by special filters and the platters are sealed in an insulated and airtight case with the interior kept in partial vacuum. This sealed chamber is often referred to as head disk assembly, that is HDA. Next is hard disk controller or the internal board, which we can see here. The hard disk controller is an internal electrical circuit board which is present just under the disk platters that enable the processor or CPU to access, read, write, delete and modify data from the hard disk, or this device tells the hard drive what to do and how to move the components. It is abbreviated as HDC and acts as a bus connecting the hard disk to rest of the computer. Now let us understand what is the geometry of hard drives. The geometry of hard drive refers to how and where the data is stored on the surface of each platter. The data is recorded on these thin circular tracks. There could be more than 1,000 tracks on 3.5 inches hard disk. Each track is further subdivided into smaller zones called as sectors. Sector is like a slice of pie, means a portion of disk between a center, two radii and corresponding arc. Remember, a sector is the smallest and basic unit for data storage or the addressable surface, which can store 512 bytes of information. Newer type of the hard drives have 4096 bytes capacity sector known as advanced format. Dear students, primary characteristic of an HDD is its capacity and performance, where the capacity of HDD can be calculated by the number of usable surface into bytes stored per sector into sector per track into track per surface. This is represented in gigabytes and terabytes. Let us now discuss few important characteristics which affect the performance of hard disks. The major characteristics are access time and data transfer rate, where the access time is the measure of time a head takes to travel the disk track until needed data is found. The average seek time usually ranges from 8 to 12 milliseconds, so the lesser the time, better is the performance. A related phenomena is rotational delay, also called as waiting time or latency. It is time taken to bring the required sector under the read-write mechanism, measured in revolution per minute, where the maximum latency is usually 60 revolution per minute and the average latency is equal to half of the latency time. Next factor which affect the performance of hard drive is data transfer rate, which is commonly used to refer how fast data is transferred from one location to another. The equation for data transfer rate is data transfer divided by time taken, therefore represented in megabytes per second. For example, a maximum data transfer rate of a hard drive can be 480 megabytes per second, but it depends upon the model and the interface it uses to function. Usually a SATA interface is used. Next factor which could affect the performance of hard drive is cache memory. Cache memory is present in hard drive controller, can greatly improve the hard drive overall performance. Means if there is a large cache, you can store the temporary data into the cache to reduce the system load and to improve the data transmission speed. Let us now move to our next important topic, that is addressing methods. Dear friends, we just read about the geometry of hard disks, where we studied how data is stored or allocated on the hard disk. And to locate those files on hard disk, we required hard disk addressing. Means this is because of addressing system that the read-write head is able to locate the desired information. Both CHS and LBA addressing methods are important for partitioning mass storage devices like hard disks and SSDs, or to allocate storage space. Let us first see what is CHS addressing. CHS addressing divides the disk into cylinder, heads and sectors. So there are two heads in two sides of each disk. A head is corresponding to one side of the disk. So head number indicates at which side of the disk the data is stored. It consists of a valid range between 0 and 254 heads. Now once the head number decides about the side of the disk where desired information is to be sought, next is to narrow down our search and precisely cylinder number is located, where the cylinder is made by combining the concentric track at the same radius on the platters. Means a series of tracks pile up vertically to form a shape of cylinder. Therefore, the number of cylinder is equal to the number of tracks. It consists of a valid range between the 0 and 1023 cylinders. Track number starts at 0 and the track 0 is the outermost track of the disk and the highest number of the track is near the spindle, where the sector, as we earlier mentioned, are the tracks which are concentric circles on the plateau, which are further subdivided into multiple sectors with a valid range of 1 to 63 sectors. So, the combination of three specific number of cylinder, head and sector could identify any sector on the device, which is smallest physical storage unit on the disk. For example, 1000, 254 and 63, where 1000 is the cylinder number, 254 is the head number and 63 is the sector number. Please remember the cylinder and head values start at 0 and the sector values start at the 1. So, the first sector of the disk is stored at CHS address 0 number of the cylinder, 0 number of the heads and 1 number of the sector. And the second sector would be stored at 0 is to 0 and 2 and so on. Now, the capacity of each sector is 512 bytes, as we earlier discussed. Using this capacity, the maximum size of the hard disk can be calculated by multiplying 1024 cylinders into 255 heads into 63 sectors, which is further multiplied by the capacity of each sector, that is 512 bytes. So, it all comes out to be 8422686,720 bytes or 8.45 gigabytes. CHS addressing is an earlier method for assigning the physical address to each sector on the hard disk drive. But the most hard drive which came after 1996 implement logical block addressing. But still, CHS addressing is used for compatibility reasons. At least we require CHS for booting purposes, where the modern BIOS can switch to logical block addressing mode using translation algorithm, that is the INT13 hex interrupt extension. So, let us go through what is LBA addressing and what is logical block addressing. Logical block addressing is a technique that allows a computer to address a hard disk larger than 528 megabytes. LBA addressing involves a completely new method of addressing sectors. As the name suggests, it uses to identify logical blocks on the hard drive, where a LBA block corresponding to the sector used in the CHS addressing. The location of block is identified through an integer index, where the first block is marked as LBA 0 and the second being LBA 1 and so on. So, it is particularly simple linear addressing scheme. A logical block address is a 28-bit value that maps to a specific cylinder head sector address on the disk by the driver controller. CHS addresses can be converted to LBA addresses using the formula as shown on your screen, where C, H and S are the cylinder number, the head number and the sector number, and the LBA is the logical block address, where HPC is the number of heads per cylinder and SPT represent the number of sectors per track. Dear friends, by now we learned about the construction and addressing of the hard drives, but it is important to mention a little about the SSDs, the solid state drives, which are continuously replacing hard drives in some laptops, reason being their high speed, durability, low power consumption, and low weight qualities. But due to their high cost and capacity concern, they are limited to notebook and portable systems. In contrast to hard disks, a SSD consists of semiconductor memory building blocks, the NAND flash, which contains no mechanical part, therefore the name is solid state drive. Therefore, a typical SSD has a less seek time between 0.08 to 0.16 millisecond in comparison to 8 to 12 millisecond as in case of hard drives. So they are very fast in access time. So better is the performance. The smallest unit of SSD is a page, which is composed of several memory cells and is usually 4 kilobyte in size. Several pages on SSDs are combined to form a block. Currently, 128 pages are mostly combined into one block, where a block is the smallest unit of access on a SSD and contains 512 kilobyte in comparison to sector in hard disk. The data are always read and written in blocks, but SSDs use a different algorithm to determine first logical sector. Therefore, partition need to be aligned in blocks on SSDs. In contrast to usual hard disks, the number of write accesses to a block in SSD are limited. That means if more pages has to be written or deleted, that can lead to an earlier failure of blocks. HDDs and solid state disk drive can be used interchangeably because of their general form factors, that is 2.5 and 3.5 inches, as well as the ways they are connected to the system, that is usually SATA type of the interfaces. But SSDs and HDDs differ in the way data is managed. It is more complicated on solid state drives than on traditional rotating media, that is hard disks. So that's all we have for you on the hard disk. But before we wind up this module, on the lighter side, let us talk few measures to increase the life of your hard disk. I suppose when you started using the computer in the school, you must have been advised by your teacher to shut down your computer in the right order. This is to evade damage to your disk. Secondly, don't vibrate the running system, as it may produce friction due to narrow gap between the head and disk platters, as we mentioned earlier. And defragment your drive at fixed interval for optimal use, and ensure a constant power supply. Otherwise, you may lose your data or damage your hard disk. And most importantly, ensure a dust-free, humid-free environment to avoid choking of superfine filter used in hard disks. All these measures are very important to mention, which may be intentionally misused to rest your disk drive. So be conscious and be alert. With this, we take a break. Hope after going through this module, you are thorough with the construction of hard disk drive and the addressing system used for storing data. See you in the next module. Practice safe use of your hard disk. Goodbye.